Hello all, welcome to the new series of GATE 22, GATE 2022 based question solution. So in this series of videos, we will be planning to do the solution for all the operating system questions. Okay, so let's start with our first question, as you can see on the screen. The question is something like this. You are given the threads T1, T2, T3 executing on the single processor, synchronized using three binary semaphore S1, S2 and S3. Operated upon the standard wait and signal, the threads can be context within any order at any time. Okay. Now they are given T1, T2, T3, T different threads, which is having S3. T3, T1 is basically handling by S3, T2 is handled by S1, and T3 is handled by S2. Which initialization of the semaphore to build the sequence BCA, BCA, BCA? So always the sequence which is required here is BCA. So they want a particular fixed sequence of BCA. Now, if you see the fixed sequence of BCA, B is basically being printed by the thread T1, sorry, thread T2. C is basically printed by the thread T1, and A is printed by the thread T3. So basically, it's a requirement that the first thread should be T2, second should be T1, and third should be T3. And they should be repeating in this fashion. So first T2, then T1, then T3, then repeat. Okay, so how you can able to achieve this? So let's say if we take the example one where all three semaphores are one, so it can go in any one. Okay, so let's say if it go to T1 first, it will have S3 value equal to 1. It will print C first of all. It will decrement the value of S3 to 0 and it will print C. So this would be total error. Okay, now we'll go with the option B, S3 is 0. Okay, even with option D, the S3 is 1, so we will ignore that option. If we go with option B, S3 is 0. Now if you go S1 and S2. So if we go with S3, it will be blocked here. So T1 will be blocked. But now as S1 and S2 both are 1, T2 will continue or T3 can also continue because T3 is dependent upon S2. So first of all, it can print A value. So that's why S2 equal to 1 is also correct. So this is also wrong. So basically, we are left with one option. Let's try to understand how it works. So first of all, we have S1 is equal to 1. Okay, it will allow only T2 to execute, which will print the value B, and then it will make the S3 equal to. Okay, the value of S3 is initially 0 in this option. It will make S3 equal to signal always increment and weight always decrement. After these, it will definitely go to T1 itself, and T1 will print C1. After this, it will make the value of S2 equal to 1. So S3 value is basically 0. It make S2 equal to 1, so it will basically go to T3 and it will print E. After this, it will make all three would be 0, but at the end, S1 will make S1 equal to 1. Again S1 1, so it will again go to T2. So it will again go to T2 and print. And this process continues in a loop. So if you understand T1, increment the value of S3, okay, T2 increment the value of S3, T1 increment the value of S2, and T3 increment the value of S1 again. This is the circular. So our answer would be very easily this. You can also check this by taking some example how S1, S2, and S3 work. So basically, if you want the first in the standard order, we only require S1 to keep 1 and everything else should be 0 in the initial action. So this is a very simple question which was asked in GATE 2022. Hope you understood this particular question and let us know for any doubt. Okay, welcome back with one another GATE question for operating system which was asked in GATE 2022. So this question was basically an MSQ question. And it's a very straightforward question. It is asking which of the following is true with respect to delta. So let's try to identify each and every option and try to check whether that is true or not. There can be more than one option true in this particular section. The first thing is circular weight is a necessary condition for the formation of deadlock. Now, everybody knows that if we have a particular deadlock, okay, we have certain conditions like mutual exclusion, no preemption, hold and wait, and the last one is circular. So all of these are basically the necessary condition for the deadlock. And out of this all, this is what is being asked. So circular weight is definitely a necessary condition for deadlock. So we can say this. So the first option is true. But as it is an MSQ, we need to check the other options first. In a system where each resource has more than one instance, a cycle in its wait for graph indicate the presence of deadlock. Okay, so this is completely wrong. So cycle would give deadlock, okay, only if each resource has single. Okay, so cycle can give the deadlock only if each resource has a single instance. Then there is a guarantee for a deadlock. Okay, so we if they can see you, okay, they are giving more than one instance. Even if a single resource is having a more than one instance, there is no guarantee for the deadlock. Okay, but it is saying that all the resources have more than one instance, then it's a deadlock. It's completely wrong. So option D is wrong. Okay, if the current allocation of the resource of the process leads to an unsafe state, then deadlock will occur necessarily. Okay, so see, if we are going with an unsafe state, it is giving us a guarantee that the deadlock can happen. In some scenario, deadlock can occur because if we are having the unsafe state, then deadlock can occur. It is more likely to be occur, but it's not necessary. There are also some scenarios in which if some of the system don't take some resource afterwards, okay, or there is some change happen to them afterwards, then deadlock will not necessarily. But it is very likely to occur in the case of the unsafe state. So we cannot say necessarily occur because of that necessarily word. We can say this is even wrong. Okay. Last thing in the resource allocation graph, if every edge is the assignment edge, then the system is not in the deadlock. Okay, so we can say assignment means what? If you see the assignment edge, it means very simple that a resource is assigned to a particular process. And if that is the case, then there is no deadlock. Okay, a very simple understanding. In that case, there won't be any particular deadlock. So this particular condition is totally true. Okay, saying that if the edge is an assignment age, if every age is assigned, means every resource is already assigned, then there is no, the system is not in deadlock because all the resources are assigned. So basically, deadlock happened if the some process is waiting for some particular resource and that resource is present with some other process. If that is the scenario, then deadlock can happen. But here, that is not the scenario. Okay, so the answer is pretty simple. The answer is A and for this. Okay, so hope you understood this particular question. That's all for this video. We'll be coming back in the next question, sorry, next video with the next question. Welcome back with one another GATE question, which was asked in GATE 2022. So in this particular question, it's also one of the MSQ question, just like the previous one. So here we are having four processes, PQRS, a schedule of the CPU at the round robin algorithm with the time quantum of 4 minutes. The process order arrives in the order of PQRS at all at timer 0. There is exactly one context switch from S to Q, exactly one context switch from R to Q, and exactly two context switches from Q to R. There is no context switches from S to Q. Switching to a ready process after the termination is also considered as the context switch. Okay, so if you are switching to another ready process after the termination of that process is also considered as a context switch. Which of the following is not possible as a CPU bus time of this process? Okay, so here they will ask that you are having a round robin algorithm with PQRS in this particular order. So let's try to understand about preparing the Gantt chart first. Okay, so first of all, we will have P. Okay, so I'm not writing the or the time of execution, but I'm just writing the sequence of execution because we are not given any particular time of execution. So the concept is like this. So P after P we will have Q. There is nothing written that there is no particular context which is from P to Q. Okay, so basically we can have a context switch from P to Q. Okay, so we can have the context switch from P to Q. Now from Q, you will have a particular context switch to S. Okay, P to Q to R. Sorry, this is standard format Q to R and R to S. Okay, now from S, we don't have any particular context switch to P. Okay, so P should be done by this particular time. So from S, we have exactly one context switch to Q. Okay, so we have made the context with this one. Okay, now let's understand. One context switch from R to Q. Okay, that's a different story. And exactly two context switch from Q to R. So now we have one context switch from Q to R. Okay, we have already done a particular context switch from Q to R previously. Q to R. Okay, now this is the second context switch from Q to R. Okay, so two context switches from Q to R is done. One context switch from S to Q is done. So this is what was required. This is done. Q to R done. Q to R done. R to S, there is nothing written that there is any particular context switch from R to S. So we are not saying anything by this way. Okay, P to Q, they haven't mentioned any particular part, so we are not considering. Now only one context switch which is left out from Q to from R to Q. Okay, so basically there's saying only one context switch from R to Q, which was left out. So basically we need to have one context from R. Okay, this is also being mentioned. Now if you look here, we followed all the particular order in which it was mentioned. First of all, it is a round robin. So PQRS is followed in that order. From S, let's say P is completed. P is completed. So from S, P is completed. So we need to go to Q. From Q, we need to go to R. And from R, we can go to Q. So this would be a round order for which PQRS would be. So basically, we can say that P executed only once. Why we cannot execute more than one for P? Because if that is the case, then we need to again have P afterwards. And we cannot do any context switch from any other one. Okay, there is basically if you are having P, then we cannot do any particular other context from here. Okay, so P will be executed. What about Q? Q would be executed 3 times. Okay, R would be executed twice and S would be executed once. And per quantum is of 4 units. Per quantum is of 4 units. Okay, quantum is given of 4 units. Okay, so basically the value of P should be in the range from 0 to 4. Okay, so if you let 3, 4, 4, 2, 3. So P is following all the standards here. Okay, the value of Q should be basically from 8 to 12 because it is running 3 times. So basically first time it will complete 0 to 4, second time it will complete 4 to 8, and then it will run from 8 to 12 any particular. So Q is 10, that is following, Q is 12, that is following, Q is 9, that is following, but here Q is 7. So we can simply say this is not our answer. We simply get that this is not our answer. We run the elimination strategy. R is 2. So first time whenever you execute it, you execute 4 units. Next time it would be anywhere between 4 to 8. So let's understand. R is 6, R is 5, R is 5. Okay, it's working fine. Here also R7, but for Q we cannot. So for PQR we are getting this. And S is also executed once. So we have from 0 to Okay, which is allowed. Okay, here we are saying which one is possible. So S is 2, which is possible, 4 is possible, 1 is. So we can simply say that all A, B, C are possible based on the time unit which is being mentioned and based on the order of sequence of execution. Okay, so once again, let me explain you how we are kept up this order because of the round robin algorithm. First, we start with Q because this is coming in this order P, Q, R, S. That's the standard rule. Now, from S to Q, if it is coming by this way, means P is completed. That's for sure. Okay, now from Q, it will go to R. Now, from R, it would have only one context switch to Q. Now, here we haven't kept S, it means S is completed. From Q, we can again keep R, but it is telling only particular two contexts. It is already being done. Q2R, Q2R. Two context switch is already done, so you cannot move ahead to R. And we cannot move ahead with the Q also, because Q will continue till particular 4 times. Okay, so that's why anything which can be allowed for the Q is 8 to 12. Even more than 12 is also allowed because Q will continue, not do the context switching. Okay, and here R is completed, then also this is considered as a context switch. S is completed, then also it is considered as a context switch, as mentioned in the equation. So our answer would be pretty simple. It would be A, B, and C. All the three would be possible with the CPU bus type which is present. Okay, so that's all for this particular question in this video. We'll come back in the next video with the next question. Welcome back with another great question for operating system which was asked in GATE 2022. So this is a fill in the blank question. Here they have asked about a demand paging system with 4 page frames. So there are basically 4 page frame which is present, and we are using the LRU page replacement policy. So basically we are using the page replacement algorithm with 4 page frame which is present. And following are the page reference string which is given. The page fault rate defined as the number of page fault on the number of memory accesses. So we need to find the number of page fault to the number of memory accesses. Okay, so let's try to understand first of all how many page fault happens. Okay, so as they have given, we have in total 4 different page frames which are initially empty. Okay, so first of all, we will have 7 which is not present, so this is one page fault. 2 not present, this is another page fault. 7 which is already present, so we don't have any page fault. 3 not present, we will add it, another page fault. 2, yeah, it's already present, so one another no page fault. 5 we will add. Okay, then 3, okay, it's already present, so no page fault. Then 4. If we now we look at 4, we look at the backwards. 2, 5, 3. This is all being included as of now. So we remove basically 7 and we add. Okay, simple. Now if you look at 6, we have 5, 3, 4. We have 5, 3, 4, and we have 6. So basically 2 was the least recently used. So we remove basically 2 and we add 6 here. Now we have 7. 7 also not present, so there's one another page fault. So 7, if you look at simple, so 7, 3, 4, 6. 3, 4, 6 was used recently, and basically 5 was not used recently. So we remove 5 and we add 7. So 7, 7 is already present, so we don't add. This is not the second 7 is not the page fault. Then we again go to 1. Okay, 1 is not present. So 4, 6, 7 is used recently. 4, 6, 7 is used recently. Only 3 is used long back. Okay, so we replace that 3 with. So in total we have 1, 2, 3, 4, 5, 6, 7, 8. 8 page faults as of. And we are at basically number 1. Now we look at 5. 5 is also not present here. Okay, so basically we check. 7, 1 is being used right away, and 6 was also used before. So we replace the 4 with 5. We replace just 4 and we make it 5. Okay, then 6 is also present. There is no page fault. 1 is also present. There is no. So in total, we have 1, 2, 3, 4 initially, then 5 different check marks. So total, we have 9 page faults. Okay, and what is here? The ratio of the number of page faults, which is 9, to the number of memory access. Okay, how many memory access we have done? So we have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in total, we have did 15 memory access. It is something similar to 3 3s and 9 divided by 5. Okay, which is 3 divided by 5. You can say it's similar to 1 divided by, okay, 3 divided by 5. Basically, you will have the value as 0.66. It will continue. But this means you have rounded to one decimal place. So our answer would be very simply 0. Which is rounded to one decimal place. Okay, so our answer would be very clear. It would be 0. So this was also a very easy question which was asked in GATE 2022. That's all for this particular video. We'll come back in next video for the next question. Welcome back with one another GATE question in the operating system series, which was asked in GATE 2022. So this is also the fill in the blanks question. Okay, so here they have asked about two different file systems, A and B, which is using the contiguous allocation and linked allocation. So A is using contiguous allocation and B is using linked allocation, which is being given inside the question. A file of 100 blocks is already stored in A and also in B. So basically we have stored this file of 100 blocks in both A and B. Now consider inserting a new block in the middle of a file. So we need to insert a new block between 50 and 51st block in the middle of a file whose data is already available in the memory. So basically we have the entire 1 to 100 block and we need to insert one new block. Let's say this is a temp block. I'm just giving the name of a temp block. It's a temp block between 50 and 51. Okay, so this would be basically our new. Okay, whose data is already available in the memory. Assume that there are enough memory blocks at the end of the file and the file control blocks are already in the memory. So basically everything is present in the memory. You don't have to bring anything from the disk. That the number of disk accesses required to insert a block in the middle of the file of A will be number of A, number of A. Hence, what is the value of NA and N? So how many different disk access would be required? So now let's identify first of all with the contiguous allocation. With the contiguous allocation, let's say A is basically having contiguous allocation from 1, 2, 3 to 50, 51 up till 100. And then there is some space which is available. So it is already given that assume that there are enough free blocks at the end of the file. So there are enough free blocks which is available at the end of the file. So you can consume that. There is no particular data to be taken in that place. Now you need to insert this temp block here. So first of all, if it is a contiguous allocation, you can directly go to this particular position of 51. You add this particular temp block and remaining 50, we just need to shift right. Okay, contiguous you can consider like an array where you will just add this particular block here and everything else you need to shift right. So 50 would be the shift right, which would be the writing, or you can say it would be the write operation which we perform. Okay, so number of disk access will be required for this 50 and this for one time. So if you are talking about the contiguous allocation, in total it will be 51 because we can directly access here by using the array based scenario. Okay, and we can add a particular block here and remaining 50 would be shift right. Okay, so in total, in the case of the contiguous allocation, we will require in total 51 disk access. So you can say the value of NA, which is basically related with the contiguous allocation, is equal to 50. Okay, so this is the concept related to the contiguous allocation. Let's discuss for the linked allocation. Okay, on the next part. So let's say we are having a B where we are having 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, pointing to 5. Similarly, we can have 50 pointing to 51, 51 pointing to 52, and let's say last one. This is the basically a linked allocation system. So in linked allocation, you cannot directly access any particular data. Okay, you need to traverse each and every particular, traverse all the blocks. Okay, so first of all, basically you can say need to traverse first 50 blocks, or you can say basically access, or you can say the read. Traverse means read first 50 blocks. Okay, then what you will do, if you have this particular pointer, you can simply say the next of 50 will become this temp, and the next of temp will become 51. So this will be one write operation. So total disk access, you can say total access, which is nothing but NB, which would be 50. 50 would be for the read and 1 would be for write. So if you look here, NA was also 51, NB is also 51. So if you combine the value of NA and NB, our answer would be 51 plus 51, which will give me the value as 10. Okay, so this is a very, very simple question. And here would be the answer of 10. So it's a very simple question. If you know the simple concept of array and linked list, you can able to solve the question quite easily. Okay, let us know in case of any particular issue you are facing. And that's all for this particular question. And these are the available questions which is present in the operating systems for GATE 2022. Hope you enjoyed all of this. Thank you so much and all the best for the future.